Hello everyone. Sometime back when using the services, I told you that we have been using only the IP addresses like the node IP and the cluster IP, but we did not use the service name. Also, when I discussed about external services, I told you that typically you would be using the service name rather than the IP address. But I have not done so. The reason is that I did not discuss something called Kubernetes DNS, which facilitates that usage of service name instead of IP address. But before going into Kubernetes DNS, I wanted to talk a little bit about DNS itself on a very high level. Anyway, I have uploaded a video from another course of mine, so it contains a little bit about DNS introduction. Just go through it if you want to, but it's okay if you don't want to. That is also fine. So the first thing is, what is DNS or domain name system? So it's very simple. If you don't want to go into the details, it maps a human readable name to IP address. For example, google.com. So google.com is maybe not maybe the most famous domain name or URL or the most typed URL in the world. It is pretty easy for us to remember google.com. But actually there's an IP address, or there can be multiple IP addresses behind that name. So whenever we type www.google.com, it has to get us an IP address so that our browser can hit the IP address directly. So what happens behind the scenes is that it goes to something called a DNS server or a name server, which would contain the mapping of google.com with an IP address 172.217.160.132. Your IP address might be different because as I am sitting in India, this is the IP address that I get when I type www.google.com. So my browser will receive this IP address back, and it will go and hit that IP address, and it will actually hit Google server. So let me just show you. So if I type Nslookup www.google.com, you get this IP address 172.217.160.132. You can use dig also. Actually, you should use dig because this is the latest one. Nslookup will be deprecated from a lot of Linux versions. Anyway, so if you see, I get the same IP address 172.217.160 and 132. So we're getting this information from a name server, which is part of domain name system or DNS. Now, if we take this information, or if we take this concept back to our on-premise data center or GCP or AWS for that matter, what we have is we have multiple servers: server 1, server 2, server 3. These are the names of the servers, not IP address. So can we use the names of the server to talk to each other, meaning the host name of the server? The answer is yes, because you might have done that multiple times. You use the host name instead of the IP address of the servers within the data center or within cloud. You can use any cloud service provider. So that means that there's a name server or a DNS server present within the data center also. So this name server, let's say the IP address of this name server is 10.20.110, would contain information about all these servers: server 1, server 2, server 3, and their corresponding IP address. Now, if let's say server 1 wants to communicate to server 2, it'll actually go to the name server, it'll get the IP address back from name server, and then it'll hit server 2. Now the question arises, how server 1 knows the IP address of the name server, which is 10.20.110. So that's why the file etc/resolve.conf come into picture. Typically, again, I'm stressing it again, typically this is the file that would contain the information of the name server. So whenever we type any host name, like server 1, from server 1 I'm typing the name of server 2, which is server 2. It'll go to etc/resolve.conf and it'll find out the IP address of the name server. Then only it'll go and hit the name server to get the information or get the IP address of server 2. So after that it'll get the information back, and then it'll go and talk to server 2 using the name, not the IP address. Now if we add more servers, let's say server 4 and server 5 have been added, the information of their names and their IP addresses would also be entered in name server automatically. There's a huge ecosystem built around DNS. There are a lot of tools available to handle these kind of things. There are so many other concepts also, but I'm skipping all those because I want to keep it as simple as possible. So this is how things work. This is how we are able to talk from one server to another server using the name. Now let me show you a small demo on GCP. So I have been using Google Cloud Platform compute engine instances to launch our Kubernetes cluster using KubeADM. So earlier I was using CentOS or Red Hat Linux. Now I'm using Debian or Ubuntu. So let's see how things work. Now, one more thing I forgot to mention is that this hcresolve.conf would be there on all the servers by default. It'll be available, and the entries in resolve.conf would be same for all the servers as well. So it's not that server 1 would have a different entry than server 2, or server 3 would have a different entry than server 4 and 5. It will never be the case. So hc.resolve.conf would always have the same entry, which would be the name server for these nodes. Okay, so this is my master server, and if I type host name, it will give me the name master. So what is the IP address of this server? If I type hostname -I, it will give you three IP addresses: 10.20.149, 172.17.01, and 10.30.01. You can type IP also to get the information. And we are bothered about eth0, which is 10.20.149. If I go to Google Cloud Console, so this is the internal IP address 10.20.149. The same would be true for worker 1 also. So now let us try to look at the IP address of master, how it is linked. So if I do Nslookup master, it tells you that the IP address of master server, or IP address of the server whose name is master, is 10.20.149. And we have another server with name worker1. Without any doubt, it gives you the IP address of worker1 also, which is 10.20.150. Okay, so now can I communicate from master to worker1 using the name of the machine, which is worker1? Let's see. Let's ping worker1, and if we get an output, which we are getting, that means that we are able to talk to worker1 using the name of the server rather than the IP address. And if we use IP address, the answer would be the same. So we're getting response from worker1 also. So now if you see, as I type worker1 here, as I'm pinging worker1, it is actually saying that it is going to ping 10.21.50. So that's how it works. Now, what about the name server? Where is the name server? If you go to hcresolve.conf, and it tells you that the name server is 169.254, 169.254. So this is the DNS server or the name server. So whenever I type worker1 from, let's say, master node, what it does is it goes and tries to find out the IP address of worker1 in 169.254, 169.254. Once it gets the IP address, then it goes and hits or pings that node, which is 10.20.159. So this is at the node level. Let's see how things are at pod level. So now it will be Kubernetes DNS, not the node DNS. So DNS in Kubernetes cluster is implemented by core DNS, and I have already shown you the pod of Kubernetes DNS. Let us go ahead and see a little bit more. Let me show the pod one more time. So these are the two pods: core DNS, some number and some random hash, and core DNS. So these are the two pods which are implementing the DNS system or the name server. So if you think about it, these two, one is actually the backup of another, is the name server for the entire Kubernetes cluster. Having said that, let's see how things work. Let's try to visualize a little bit more. So you can use either GCP or AWS or Azure also. Now this is my cluster. So we have node 1, node 2, node 3, node 4. Node 1 is the master node and remaining are the worker nodes. We have name server at node level. So in case of GCP, you have seen that is 169.254, 169.254. And it is same for AWS also, I guess. Now this hcresolve.conf would be there in all the nodes. Node 1, node 2, node 3, node 4, all of them would have hcresolve.conf. Now, as I said, node 1 is the master node, and node 2, node 3, node 4 are the other three worker nodes. And all of them have hcresolve.conf, which is pointing to 169.254, 169.254. Now we have these pods, pod 1, pod 2, pod 3, pod 4. For simplicity's sake, I have only kept 4 pods. And this is the core DNS pod, which is there in the master node. So core DNS is providing Kubernetes the DNS system, or the DNS server, or the name server, whatever you might want to call it. Now when you create a service, the service entry is also made in core DNS, which is nothing but the name server. Now this service has been built on the deployment which has launched these two pods, pod 3 and pod 4. Now let's say pod 1 wants to talk to this service. Now what happens here is that pod 1 goes to core DNS, gets the IP address of the service, and then goes and hits the pods, because then service kicks in and hits the pods on a load balanced fashion. So now the question again arises, how the pods know where to find the mapping of service and IP address. So in case of nodes, we had resolve.conf in all the nodes. Now interestingly enough, we have hcresolve.conf in all the pods also. And that hcresolve.conf would actually point to the core DNS IP address or the service. So the pod 1 would consult hcresolve.conf, which is there in itself, and then it'll go to core DNS and then get the IP address, and then it will go and hit the pod. So that's how DNS helps in Kubernetes. So we can use the name of the service without the IP address, which we'll see in our demo. So there are some namespace considerations. So let's say you have a service in a different namespace. What you have to do is the way you address that service is by this. You have to mention the service name followed by the namespace name .svc.cluster.local. If it is in the same namespace, you can just mention the service name or service name.cluster.local. So let's see a demo. The first thing that we'll do is we'll see the DNS implementation in Kubernetes a little bit more.